Hey Math 2, Mrs. Bricky here, making the video for topic 2. I hope you're all enjoying doing math at home. Let's see, so this is a review topic, so hopefully it won't be too difficult for anyone. Again, if you have questions or get stuck on anything, you can contact me or Mr. Fairborn and we are happy to help you out. Definition of a sector, hopefully you remember this from our last unit. A sector is a portion of a circle, and it's bounded by a central angle and its intercepted arc. So we have a central angle here and its intercepted arc, and that encloses the sector of the circle. So you can think of a sector like a slice of pizza. So we've talked about the equation for calculating the area of a sector before, but the easiest way to think about it is that you just think about what fraction of the circle you have, or what portion of the circle you have, and then multiply that by pi r squared, which is the area of the entire circle. So we'll be using this formula. I think in the last unit we used theta instead of x. So x maybe will be a little bit more familiar. I know some of you don't like theta very much. Theta haters. All right, so here's our first example. We've got a circle. That central angle is 51 degrees. And we want to find the area of this sector. So the area is 51 over 360. And we're going to multiply that by pi times the radius, which is 16 squared. So there's a lot of ways you could put that into your calculator. Probably for most of you, you're comfortable using that fraction button. So 51 over 360 times that by pi times the radius squared. Now on a lot of these, your calculator will probably leave it in terms of pi. So just use the little converting button right there above the enter to get the decimal approximation. And I think all the answers on the back of your worksheet are in decimals, but I can't remember. So 13.94, and our units are going to be square feet because we're finding area. So the radius was in feet, the area will be in square feet. So there's our first sector. On this one, it doesn't have any numbers given, so make sure you're watching out for symbols that are giving you information. So we've got this right angle right here. That means that's a 90-degree angle. So if we need to know this shaded angle, that angle, I'll call it x. X is just going to be 360 minus 90. So that's 270 degrees. So now to find the area of that shaded sector, it's our central angle divided by 360, and we multiply that by the area of the circle, pi times radius squared. And the radius there is 29.5. Okay, so in the calculator, we'll calculate that really quick. 270 over 360 times pi times 29.5 squared. And we get that the shaded area is 2050.48, and our units are miles, so that area would be square miles. Okay, another one. Again, we know that the non-shaded angle is 42 degrees, so our angle is going to be 360 minus 42. So that would be, I got to do it in the calculator because otherwise I'll mess it up. Okay, 318 degrees is our shaded angle. All right, so if we want to calculate the area, we use our central angle, we divide it by 360, and we multiply that by pi times the radius squared. Radius is 9. Pi times 9 squared. All right, and again, use that converting button to get the decimal. So the area of that sector is 224.78. Our units are square inches. Okay, so these next couple have a little bit more complicated shape to them. It'll have maybe more than one section that is shaded. So if you do have a section, a couple of sections, you can just find the total shaded angle and use the exact same formula that we have been using. So we have a 46-degree angle here, but then this is a vertical angle to that, so it is also going to be 46 degrees. So the total shaded central angle is going to be 46 plus another 46. So that's a total of 92 degrees. So to figure out the total area, we'll use that 92 degrees. And it says that HG is 7. So that's the radius, 7 squared. And you could have found the two areas separately using 46 degrees and then just added those two areas together. So either way, if your brain sees it better to think of those two areas separately and then add, you definitely could do that. Okay, so our angle was a total of 92 out of 360, and then multiply that by pi times radius squared. Get a decimal there, 39.34. And that is, our units are centimeters, so centimeters squared. Okay, on this one we again have two sections. The angle that we're given though here is not a shaded angle, so I'm going to use the fact that this is a diameter of the circle to find what this shaded angle is. We know that the shaded angle that I marked plus 143 add up to 180. That's linear, a linear pair right there. So 180 minus 143 tells me that that's a 37-degree angle. And then the other side is vertical from that, so it's also going to be 37 degrees. So the total angle shaded is going to be 37 plus another 37, or 37 times 2. So that's 74. So our area of our shaded portion is going to be 74 over 360 times pi times, and let's see, what's our radius? We know that EB is 10.4, and that is the radius of the circle. And we need to square that. So let's enter that into the calculator. Times pi times 10.4 squared. We get 69.85. And our units are inches squared this time. All right, so I think we have one more, maybe two. Two more. All right, so on number 6, one thing to be very careful of here. We are given the length of JM is 10. 10 is the diameter of the circle. So that means when we are completing this problem, we need to divide that 10 by 2. The radius of our circle is 5. And that's what we'll use in our formula. So do watch out on your homework. There were a few that had diameter given to you. Just make sure to divide that diameter in half. Okay, so for the angle on this problem, we're given this 58-degree angle, plus we have this whole other side of the circle. So that would be a 180-degree angle. So to find the area, we'll just add those two angles together. So that's 180 plus 58. So 238 degrees. All right, so to calculate the area, we'll take that 238-degree angle, divide it by 360, multiply that by pi times the radius squared. So we're using 5 for the radius, not 10, because 10 was the whole diameter. So 238 over 360 times pi times radius squared. Let's see, let's get a decimal there. All right, so the area of the shaded portion is 51.92, and our units are millimeters squared. Okay, last one. We have some markings on our arcs that indicate that this arc is the same as this arc is the same as this arc. Well, that means they all have the same central angle as well, 62 degrees. So if we want to know the shaded portion is going to be 360. Whoa, I missed the 0. 360 minus 62 minus 62 minus 62. We want to take away those white angles that are not shaded. So we're going to subtract to get our shaded portion. So the shaded angle total is 174 degrees. All right, so now we can calculate our area. The total shaded area is 174 divided by 360. Multiply that by pi times our radius squared. Let's see, PC, that is our radius. PC is 12. Good handwriting. So that's a 12 for our radius, and we need to square that. So in the calculator, you will divide that, multiply it by pi times 12 squared. (218.65 centimeters squared). Okay, so that's it for our examples of this topic. Two quick little reminders, I guess. If you need the reference sheet for this unit, I did copy it on the back of the cover page of the unit, but I also put an extra reference sheet as the last page in the packet. So if you hadn't noticed that before, then there is a reference sheet as the last page of the packet. You could rip that off the back of the packet and use that throughout the unit if you want. And then my second thing I wanted to tell you about is if you don't have a calculator at home with you, if you left it at school, or if you've lost yours, or if yours is broken. A lot of these problems you could just do on your phone calculator, but if you do come across some that aren't working very well on a phone calculator, you can use online calculators. I'm going to show you one really quick that you can use if you want. You maybe have used Desmos before for graphing, but when you type in desmos.com, one of the options right here is that you can grab a scientific calculator. And so this has really easy, good input. You can do all of these problems just like you do them on our little TI calculator. So if you are needing a calculator option, that's one that you could use. So I just wanted to show you that, and that's just desmos.com, and click on this scientific calculator. So right here, this button. Okay, so again, let us know if you're having any problems or any difficulties, and we will absolutely be happy to set up an appointment to help you. Thank you.